Hi guys, this is video 3-6. You'll see the checklist for when to watch it. And this is on implicit differentiation and finding the equations of tangent lines and normal lines. So let's just draw a picture over here. Let's draw a curve like that. Okay, and let's put a point there. And let's say that this is the point of tangency. The tangent line would look like this. Okay, so something like this would be the tangent line, and its slope is called the derivative. So this would be the tangent line. And the normal line, and let me go like f of x. We'll say that f of x is that function. So that's the tangent line to f of x at that certain point of tangency. The normal line is perpendicular to the tangent line. So then if you draw, I'm just sort of eyeballing it, if you go like this, the normal line also goes through the point of tangency, but it is perpendicular to the tangent line. So this is called the normal line. All right, so we've already written equations of tangent lines. We're also going to do equations of normal lines. And I don't know honestly why they're called normal lines. I know that there's other contexts in higher math where normal means perpendicular, but I don't know how that relates to our regular English use of the word normal. But anyway, so we're going to do this example. So for the graph of this, which by the way is the graph of a circle, it has a center 0, 0, and it has a radius radical 13. Find the equations of the tangent lines and the normal lines to the graph at that point. Now I kind of like laid it out for you here. That won't necessarily happen like on the AP test or in the future, but I laid it out with tables so we can, clearly see the information that we need. So first we'll do the tangent line. We need the point or maybe the points of tangency because, this is a circle. So we're definitely going to have, okay, let me just keep going and then I'll say that later. So the points of tangency, it's early in the morning, so I'm a little slow. All right, I don't know what they are, but I know that their x-coordinate is going to be 2. And I don't even, I'm sort of assuming that I've got more than one of them. But so I've got an x-coordinate of 2, and then I just need to find the y-coordinate. Well, they're giving me an equation up here that relates x and y right off the bat, so maybe let me write it down. So x squared plus y squared equals 13. I'm trying to find the y-coordinate or coordinates that correspond to this x-coordinate. So I'll just plug in that for the x-coordinate. So this is 4 plus y squared equals 13. So this is y squared equals 9. And then this is y equals plus or minus radical 9, which is 3. So we actually are going to have 2 points of tangency. We're going to have 2 comma positive 3 and 2 comma negative 3. So 2 points of tangency there. Maybe I should be more professional, and I don't know that that's not professional, but I know that this is clearer. So we're going to have these 2 points of tangency. So 2 positive 3, 2 negative 3. Yeah, so there's the points of tangency. Now, let me show you a picture. All right, so this is a picture. You don't have to write this down, but this is what our circle looks like because it has center 0, 0, and the radius is radical 13. And, wow, I messed up. Darn it. Should be the other way. Okay, so there's like 2 positive 3, 2 negative 3. So these are the points of tangency. right now we are looking for the equations of the tangent lines. Since we got 2 points of tangency, we're going to have 2 tangent lines. It makes sense that we'd have 2 tangent lines because they wanted us to find the equation of the tangent lines and normal lines to the graph at this point. Well, a circle is not a function. It doesn't pass the vertical line test. So it's going to have 2 y's for a lot of its x's. And if it has 2 y's that correspond to the x value of 2, then we'll have 2 points of tangency, hence 2 tangent lines. And notice their slopes will not be the same. This one will have a negative slope, that one will have a positive slope. Speaking of slope, how are we going to get the slope? In calculus, whenever you hear the word slope, you've got to think derivative, all right? So you need to know that the slope of the tangent line is the same, I'll go like this, is the same as y prime, or I'll say dy dx, because we're going to have to do implicit differentiation because y is not solved for. Y prime or dy dx is going to be the derivative, and that'll give us the slope at any point we want. So I've got to find the derivative. So I'm going to go d dx of x squared plus d dx y squared equals d dx 13. All right. Now with implicit differentiation, you do chain rule on everything. So derivative of x squared is 2x. That's like the outside function. And then the derivative of the variable, which is the inside function, is dx dx plus 2y dy dx equals 0. After you do implicit differentiation on everything, which is essentially chain rule, a version of chain rule, then you could turn any dx dx's into 1. And just to make my life easier, I'll change the dy dx to a y prime. So 2x plus 2y y prime equals 0. So 2y y prime equals negative 2x. So y prime is negative 2x over 2y. So y prime is negative x over y. All right, that is dy dx, or y prime. That's going to give us the slope of the tangent line at any point that we want. So now I've got to use the point slope formula. I'm going to have 2 equations, so I'll use it twice. So I've got the point of tangency, and then I need the slope of the tangent line. Point of tangency, slope of the tangent line. So I'll do 2, 3 first. The slope of the tangent line is going to be y prime, which I know is negative x over y. So y prime is equal to, at this point, negative 2/3. And then I can just go y minus 3 equals negative 2/3 x minus 2. And that would be the equation of this tangent line. Okay, now for the next one, the point of tangency is 2, negative 3. I've got the same derivative, but I'm plugging in a different point, so I'm going to get a different slope for that tangent line. So y prime is negative 2 over negative 3. So y prime equals 2/3. So y minus negative 3, so that's plus 3, is 2/3 x minus 2. And that is the equation of this one. Now for the normal lines. For the normal lines, you still do the points of tangency, and we're using the same x-coordinate. They want the tangent and normal lines at the same x-coordinate. So we're still going to have 2, 3, and 2, negative 3. But the slope of the normal line, the slope of the normal line, I'll say m norm. That's the same as the negative reciprocal of dy dx, because normal lines and tangent lines are perpendicular to each other. So they're going to have negative reciprocal slopes. So let me draw you a picture. So here at 2, 3, my normal line is going to look something like that. And at 2, negative 3, my normal line will look something like that. Let me just extend that. Doesn't really matter, but... Okay, so I need the equations of the green lines. And they're going to have the negative reciprocal slopes of the pink lines, which were the tangent lines. Okay, so over here... Okay, so I know that y prime is negative x over y. So let me just say that. So norm is going to be equal to the negative reciprocal of this. You just, you flip it and you change the sign. I'm hesitating because I'm teaching this a little bit different than last year, so I hope that this is better. I think it's going to be. Yeah. All right, so now we're ready. So we still use the point of tangency. All right, the normal line still goes through the point of tangency, but we're going to be using the slope of the normal line. So we still need point of tangency, and then here we need m norm. So the point of tangency here will have 2, 3, and then m norm is it's going to be y over x. So it's going to be 3 over 2. But guys, another way you could have done, if you already knew that that was negative 2 over 3, if you already had the numerical slope of the tangent line, then you could, maybe it's easier for you. That's how I did it last year. I just had them take the negative reciprocal. I had them find the slope of the tangent line and then take its negative reciprocal. So that's another way of doing it. Okay, so then I just go y minus 3 equals 3 halves x minus 2. And that is the equation of this green line. And then point of tangency, slope of the normal line, 2, negative 3. Again, it's y over x. So negative 3 over 2, which happens to be the negative reciprocal of that tangent line slope. So y plus 3 equals negative 3 halves x minus 2. So that is the slope, or that is the equation of that green line there. Okay, talk to you soon. Bye-bye.